this short video is about limits. The limit of a function, f of x, is the value that a function approaches as x approaches a given value. So in other words, closer you get to x, what's the y value? If a function is continuous at the point in question, then the limit exists. If we have a discontinuous function, for example, if we had something that was like this, we couldn't find the limit at that point. Okay, so just bear that in mind. The function has to be continuous at the point in question. So, let's look at this question here. We've got the graph of, I've drawn the graph of y equals 3x plus 1. Okay, that's the graph that I've drawn. Y equals 3x plus 1, that's the green graph there. And we're asked to find the limit of 3x plus 1 as x approaches 1. Well, if we put x equals 1 into there, okay, we get 4. So the closer that we get to 1 here, from either direction, okay, closer we get to 1, the closer the y value will be to 4. At 1.01, very close to 1, the y value will be very close to 4. And at 0.99, which is very close to 1, the y value will be very close to 4. The closer we get to 1, the closer the y value is to 4. So how do we find a limit? Well, it's usually just a matter of, if it's continuous at that point, which it is, of just substituting in for x. Okay, so you can see there, if the function is continuous, if I just put a square around this, if the function is continuous at the point in question, then the limit exists and can be found by direct substitution. So that's what I've done there. I've just substituted my value, x value, and I got that from here. Okay, the closer that as x approaches 1, then y, well, the function approaches 4. So my answer is 4. So direct substitution is the way to go. If I want to find the limit here of this left-hand one as x approaches 5 of x squared minus 3x, I simply put in the value of x equals 5 into the equation. So I get 5 squared minus 3 times 5. Oops. 5 equals 25 minus 15 equals 10. So the closer I get to 5, the closer the y value, closer f of x is to 10. Next one, same deal. I put in 0 for x. Quite straightforward here. There we go. Top line will just be 6. Bottom line will just be 3. 6 divided by 2. 6 divided by 3 is 2. So the answer there is 2. What about this question here? Limit as x approaches negative 3. Now, if I just directly substitute in here, I get myself in a little bit of strife, because you'll notice if I put in here, if I put in neg 3 into there, what's the bottom going to be? Neg 3 plus 3, the denominator will be 0. We can't divide through by 0, so we need to be careful here. We still can find the limit. What we're going to have to do is factorise the top. And in fact, in the previous question, the safe way there would have been to factorise first. Okay, let's have a look. If we factorise this, we get, excuse the vacuuming outside, we get x plus 3. Actually, what I might do is just write the question out again. Sorry. So what we're going to get is limit as x approaches negative 3 of x plus 3 times x plus 2 over x plus 3. So I factorise the top. Now what happens is I get cancelling out there. So it just becomes, there's a 1 in the denominator now, the limit as x approaches negative 3 of x plus 2. Now I substitute in the negative 3. Negative 3 plus 2 equals negative 1, and that's my answer. So if you find yourself substituting and you get 0 in the denominator, please look at that option of factorising first, and an answer can still be obtained. So that's a bit of an introduction to limits. If you could please have a go at exercise 7b, page 328. You can look there at questions 1, 2 and 3.